Final session of the Emerald-Ashborer University. Today's speaker will be Nate Siegert from the U.S. Forest Service, and your narrator. My name is Bob Bruner. I am the Exotic Forest Pest Educator with Purdue University Department of Entomology. Today, Nate's going to be talking to us a little bit about a bug we're all very familiar with, Emerald Ash Borer, and some of the implications of it. Nate, it is all yours.
All right, fantastic. Thanks, Bob. Good morning, everyone. Thanks for tuning in today. As Bob said, I'm a forest entomologist with the U.S. Forest Service. I'm based out of Durham, New Hampshire, but I worked a long time. I'm from Michigan, and I've worked with emerald ash borer since we discovered it in 2002. So my presentation today is about the spread of emerald ash borer, its impact on black ash, and in turn, its impact on indigenous culture. So I've worked with tribal partners on EAB and black ash for many years, and the project I'm going to talk about today was an opportunity to collaborate with both indigenous knowledge keepers and Western science subject matter experts to quantify and forecast the cultural impact of the EAB invasion. That's a profoundly sad and distressing situation for many people. And we hope that by sharing it with a broader audience, it will increase the awareness, opportunities, and partnerships among land managers, scientists, and indigenous communities. So black ash is an ecologically foundational species and an integral component of hydric hardwood forests in eastern North America, where it often dominates in environmentally sensitive riparian areas along streams, rivers, and lakes, and in forested deciduous wetlands. And as I alluded to at the onset, black ash is a cultural keystone species for many tribal nations, people in the US, and First Nations people in Canada, many of whom consider it to be a cultural, spiritual, and economic resource and use it for ceremonial activities and centuries-old basketry traditions. Black ash is also commonly known as brown ash, swamp ash, or basket ash. Here's an example of a black ash stand in New York and a traditional basket tree harvesting area for the St. Regis Mohawk tribe. To me, a large, healthy black ash stand has a certain warmth, kind of a welcoming glow about it. I certainly think that it's because there's often little understory. The bark is light gray in color. The canopy is high and bright green. And on a sunny day, it's really quite distinctive. Although you often have to have muck boots on or hip waders to gain access. And often the black flies, mosquitoes, and deer flies can be voracious at various points through the summer. But, drenched in DEET, it can be quite spectacular nonetheless. So black ash grows in northern forests from Minnesota to the Canadian Maritimes, shown here within the black ash. The black ash is shown within the North American ash range in this darker area with the hatched lines. Black ash stands can vary in size, ranging from large, nearly pure stands with thousands of trees to much smaller stands in areas with poor or consistent drainage with only a handful of trees. It has several adaptations that allow it to grow in areas that are subject to overflow and inundation of varying frequencies and durations, including shallow rooting, adventitious roots, and hypertrophied lenticels, as shown in this image right here, this inset. These are enlarged cells that allow for increased oxygen diffusion along the stem when growing in saturated oxygen-depleted soils. And they're not always visible, but can form after only a few days after flooding. So these adaptations also make them sensitive to drought and fluctuations in water availability, resulting in variations in radial growth, as shown in this cross-section, and the line graph of annual ring widths. So black ash decline as a result of drought or changes in hydrologic flow have been observed for decades from Minnesota to Maine. Shallow rooting additionally makes them susceptible to winter freeze-thaw injury. Tree ring studies have shown radial growth to be positively correlated with various measures of moisture, such as precipitation, stream flow, and spring flooding. For instance, the figure on the right here is from a recent study in New York, and shows radial growth was positively correlated with Palmer Drought Severity Index from April to June. So black ash is a ring porous tree, which means that each annual ring starts with these large water conducting early wood vessels and ends in these very narrow late wood cells. Early wood vessels are formed while the tree still appears dormant in the spring and transport water to the buds during leaf expansion. Black ash grows better in sites with hydrologic flow through the stand. Even though you might walk into a stand and think like this is just a wet, swampy area, the best growing black ash tend to grow in areas where there is some kind of slow hydrologic flow through the stand. Sites where water just collects and stagnates tend to have poor radial growth. This isn't just important from a forest health perspective. Both radial growth and this ring porous wood structure are factors in black ash's role in basketry. So indigenous basket makers prefer growth rings to be a certain width. Too narrow and the basket materials are too weak and may break. Too thick and they just aren't as flexible and may splinter when bent. So while it varies a bit from basket maker to basket maker and depends on the type of basket they're producing, the general preference is to select a tree with growth rings that are approximately 2 millimeters wide or about the width of a nickel. Ring width can vary quite a bit among and between sites, as shown in the figure here on the left. The box and whisker plots here show the range of average 25-year ring widths for trees at 13 sites in New York. The green line right here can be considered the optimal ring widths. Some sites were pretty spot on, as you can see, while other sites were highly variable or had ring widths that were much too narrow for basketry purposes. Indigenous log harvesters often check the ring widths of a potential basket quality tree before they fell it to make sure it has the growth rings suitable for basketry. The image here on the right shows a culturally modified tree with a scar from having its growth examined with an axe. This particular tree ultimately didn't have the ring widths the log harvester was looking for, and it wasn't felled. And it's not uncommon to find trees with similar wounds in traditional black ash harvesting areas. Not all black ash trees make for good basket quality trees. The presence of bends, wounds, branches, and other factors affect basket quality. Similar to optimal ring widths, the number of basket quality trees in an area varies considerably. The figure here on the right shows the average basket quality rating for trees at the same 13 sites in New York, with trees rated on a scale from 1 to 10, with 1 being poor basket quality and 10 being good basket quality. Average basket quality rating was high for 3 of the sites, intermediate at the others, and poor at the rest. Visual assessments of basket quality and ring width measurements don't necessarily correlate, though. That is, you may see a tree that looks like a decent basket tree when you're out in the woods, but it may still have less than optimal ring widths for weaving. As a result, basket quality trees tend to comprise a very minor component of black ash stands. While other materials such as birch bark, cedar, sweetgrass, and porcupine quills are often used or incorporated into baskets, black ash is paramount and in many cases considered sacred due to its cultural value. In addition to its cultural significance, black ash is lightweight, has mechanical properties such as strength and flexibility when green or seasoned that are superior to other species for basket making. Black ash splint basketry is a centuries-old cultural tradition that cannot be adequately replaced with alternative materials. While the skill and creativity of indigenous basket makers is virtually boundless, most black ash baskets may be categorized as either utilitarian work baskets, such as these pack baskets or potato baskets, or as fancy baskets that often incorporate additional materials, colors, and weaving techniques. So I thought I'd walk us through kind of the black ash basketry process for those of you that aren't familiar with it. The process starts with acquiring a log from a basket quality tree. So some basket makers will go out and assess and acquire logs themselves, whereas others rely on experienced log harvesters to supply them with basketry materials. And again, basket quality trees tend to comprise a very low percentage of a black ash stand, with things like form, size, growing conditions, and tree ring widths being important factors in determining basket quality. Next, whole or partial logs are pounded in an overlapping pattern using a mallet or the back of an axe. As you can imagine, skill and precision are a must here. People have made mechanized pounders before, and it seems like the results have been pretty mixed. In general, they tend to yield lower quality materials, but even more importantly, some basket makers simply prefer using materials produced through the traditional methods. So this pounding actually separates growth rings into distinct layers. What happens is the large early wood vessels that I showed earlier, right here in each ring, break when they're pounded and separate into these individual bands of growth that you can see on this log here after pounding. Pounded logs are scored to remove strips of these separated growth rings known as splints. And the splints align with the wood grain and are essentially long bands of the late wood fibers, which make them incredibly strong and resilient. Splints are processed further into thinner, more pliable material. And once they're at the desired thickness, they're gauged and trimmed to be the desired length and width of the material for the baskets. Trim splints may be then meticulously woven into artistic or utilitarian baskets. And I think it's worth noting that really it's the hands-on connection through this journey from tree to basket is an important one. And its value only becomes more amplified through the artistic expression of the basket maker. Indigenous cultures suffered greatly post-European contact as U.S. government policies put in place in the 1800s forced assimilation and resettlement of tribal nations. Following the termination of these policies in the 1950s, a return to cultural roots and traditions began, and the number of basket makers reached an all-time low in the 1970s. And since then, several tribal nations have worked diligently over the last several decades to increase those numbers by passing cultural values and the knowledge of traditional basketry onto younger generations. Today, black ash remains an important part of Indigenous creation stories and culture throughout its range. Of the historically Eastern affiliated tribal nations in the US, there are presently 54 still located in states with black ash. It should be noted that these are only really the federally recognized nations. There are many additional state-recognized Native American bands or tribes, as well as others that continue to petition for federal or state recognition. Furthermore, some states don't have federal or state-recognized tribal nations, such as New Hampshire, yet Abenaki culture is prevalent. So then EAB happened. And I imagine most of you are pretty familiar with EAB. It was discovered in North America in 2002. Reconstruction of the EAB invasion indicates that it was killing ash trees in southeastern lower Michigan by 1997 and had likely arrived and became established by at least the early 1990s. Its introduction, coincidentally, is located in the approximate longitudinal center of the Black Ash Range. Our North American ash species have a gradient of susceptibility to emerald ash borer. Unfortunately for this story, black ash is highly vulnerable and to date is the most susceptible of our North American ashes. Individual trees can die after only 3 to 4 years of infestation, and whole black ash stands in 7 to 8 years. In mixed ash species forests, black ash will die earlier than the other ash species present. And here you can just see this is a a site I'm going to talk a little bit more about later. It says white, this blue line's white ash, and the black line is black ash. And you can see that it declines quite rapidly from EAB infestation. So not only does the tree mortality happen sooner, but it often takes fewer EAB to do it. For example, the image here on the left is an EAB-killed black ash with fewer larval galleries than a similar sized dead green ash on the right. So as EAB continues to spread and invade new areas, we're losing black ash at an alarming rate. Often the loss of black ash goes unnoticed. It's not a timber species or a commonly planted, tree species on streets or in residential areas. So it's often out of sight, out of mind. Not many people spend a lot of quality time in wet, swampy areas around black ash trees, so it just goes unnoticed. Mortality of overstory black ash in these wetland ecosystems can drastically affect their vertical structure, nutrient dynamics, and ecological integrity. Post-invasion assessments of black ash have shown that the abundance of ash regeneration, including saplings and seedlings, can vary substantially. For example, in aftermath forests in northern Michigan, black ash saplings were generally plentiful, but seedling density was minimal, especially in riparian areas where thick mats of sedges became established as overstory ash died out. No doubt, as many of you are aware, EAB has been spreading since we detected it in 2002. The maps here show the EAB regulated area in yellow and the range of black ash at 6-year intervals from 2002 to 2020. The EAB was federally deregulated in January of 2021, and while individual states may continue to monitor for emerald ash borer, the national EAB survey was discontinued. We used EAB regulated areas from 2002 to 2020 as a proxy to estimate regional spread. So from here on out, we're going to largely focus on areas within the range of black ash. So again, the map on the left shows in yellow the EAB regulated area in 2020 for states and provinces, but this time only for those within the black ash range. Since 2002, the percentage of the black ash range within the EAB regulated area has steadily increased. By 2020, approximately 60% of the North American range of black ash was within the EAB quarantined area. While regulated areas may not be generally infested, being within a regulated area means that trees are in closer proximity to infested areas, and there are fewer restrictions for movement of infested material within those zones, thus putting them at higher risk than those outside of the regulated areas. Tribal nations in the US within the black ash range are not as evenly distributed, but show a similar trend, with the proportion of tribal nations within the EAB regulated area steadily increasing since 2002. As of 2020, more than 70% of the tribal nations in states with black ash were already within the EAB regulated area, increasingly putting their black ash resources at risk of being impacted by the emerald ash borer infestation. And just to be clear, that 70% doesn't include any of the First Nations in Canada who are likewise impacted. So we evaluated directional spread of emerald ash borer along cardinal and intercardinal directions from 2002 to 2020. And since map projections distort directional transects, we use geodesic distance in our evaluation to account for distortions. Specifically, we used bearing and geodesic distance from the EAB epicenter to the centroids of counties or civil divisions on the leading edge of the EAB regulated area each year. Historic spread of emerald ash borer from the reconstructed epicenter between 2002 and 2020 averaged 48.5 kilometers per year. That's about 30 miles per year. Spread rates didn't differ significantly by direction or physical barriers such as the Great Lakes, and state regulatory decisions such as decisions to quarantine individual counties versus entire states at once, contributed to the variability of spread rates, but didn't affect long-term directional trends over the nearly 20-year data set. This isn't completely unexpected since emerald ash borer spread is characterized by stratified dispersal, which is short distance natural spread of the insect, and anthropogenic long distance spread by people moving infested material farther afield. It's this stratified dispersal at local, regional, and national scales that greatly increases spread rates. So knowing that emerald ash borer has been spreading nationally in every direction about 50 kilometers per year since 2002, we can reasonably parameterize spread models to forecast EAB range expansion within the range of black ash for the upcoming years. We did that using a simple expansion model of 50 kilometers per year. The orange colored counties and the civil divisions here show modeled spread by 2026 within the range of black ash. We didn't consider a county or civil division to be infested until the modeled EAB spread reached its centroid. So spread just into a corner of a county, for instance, didn't make the county light up as positive. Again, trying to be kind of conservative with our approach and consistent with how we estimated EAB spread. Even with this conservative 50 kilometers per year spread, emerald ash borer is predicted to be introduced to counties and civil divisions across most of the black ash range by 2026. The only areas not within this modeled spread are in the upper right, including Anacostia Island and then the Gulf of St. Lawrence, and the little area with black ash in Newfoundland. Hopefully these areas are isolated enough to avoid introductions and stay EAB free for some time. So adding the modeled spread to our figure of the percentage of the black ash range impacted over time looks like this. Nearly complete coverage of the range by 2026 and complete coverage by 2031. We also modeled the expansion of the EAB footprint with a reduced rate of spread to simulate potential effects of future management tactics and/or possible differences in EAB population dynamics in more northerly latitudes. We reduced spread by 50% or made it 25 kilometers per year, which is approximately only 15 miles per year. Even with this best case scenario simulation, we find that nearly complete coverage of the range of black ash by the early 2030s and complete coverage by 2040 or so. So it buys us a few years, but certainly not as much as we were hoping. Next, we pulled the forest inventory and analysis data and examined the current black ash density to the pre-EAB densities. And you can see between these two figures here, you can see noticeable differences, especially in the lower peninsula of Michigan, where emerald ash borer has been established the longest. When we compare changes in black ash basal area to county level EAB detections, this is what we see. Change in basal area was variable, but increased in counties that either didn't have EAB or EAB was only recently detected. So these black ash stands were growing as you would expect them to. Counties infested for 5 to 9 years were again variable, but had put on growth, but not as much. And it's not until a county is infested for more than 10 years do we see heavy losses in black ash basal area. And the variability is much lower, meaning that individual counties infested for that length of time are all losing considerable black ash basal area. Note the lag between an infestation in a county versus an infestation in a black ash stand. Recall that I told you earlier that black ash is highly vulnerable and we can lose stands in 7 to 8 years. Here we're not seeing losses until 10 years after detection, and that's because the detection in a county could be anywhere and not necessarily close to the FIA plots. That also accounts for some of the variability in the 0 to 4 and 5 to 9 year categories. So I'm going to talk about basal area losses, which some of you may not be as familiar with, and thought I'd include an example of what that can look like in terms of of ash inventory data. So here's some inventory data from a black ash stand. This is approximately 200 trees with a distribution of size classes that is fairly typical of black ash. Most are in the 1 to 5 inch diameter class, fewer in the 6 to 10 inch diameter class, and the fewest in the 11 to 17 inch diameter class. Occasionally, depending on the site, we can find black ash in the larger size classes, but those really big black ash tend to be few and far between. So 25% basal area loss looks like this. We lose a few stems from each of the size classes, generally with a heavier percentage from the larger size classes. At 50% basal area loss, most, if not all, of our largest black ash have died, and maybe about half of our 6 to 10 inch diameter class. Maybe 80% of our smallest size class remain. Keep in mind that live trees here are often in decline. They're just not dead yet. So they might be, heavily declining canopies, lots of epicormic shoots. They're on their way out, but they're still alive. So at 75% basal area loss, things are looking pretty rough. Only a low percentage of the 6 to 10 inch diameter trees remain. Oops, go back here. At 95% basal area loss, we generally have only live trees remaining in the 1 to 5 inch diameter class, and most of these are at the lower end of that range in the 1 to 2 to 2.5 inch diameter class. So here's some data from an infested forest with black ash and white ash that I've been assessing annually for several years. This data set has fewer black ash trees than my earlier example, but a similar distribution, and is presently at 95% basal area loss of black ash. So as of August 2024, I'm down to only 8 live black ash trees, averaging about 2.5 inches in diameter. And of those remaining black ash trees, only one has a healthy crown, and the rest have a range of canopy dieback. So combining our EAB spread model with expected basal area losses, this is the pattern that emerges. Heavy losses across the lower peninsula of Michigan in 2020, which coincidentally match what we've been finding in post-invasion assessments. By 2025, EAB will have been established long enough across much of the lower Great Lakes region that heavy black ash basal area losses are likely. And by 2030, things look pretty grim for black ash in the southern part of its range. Parts of the northern tier from Minnesota to Maine and much of Canada should still have stands without too much loss of black ash basal area. Estimates suggest that it doesn't last long. By 2035, which is really about a decade away, much of the range of black ash is likely to be incurring EAB-induced damage and heavy losses. Here we have the 4 categories of basal area loss in relation to the estimated amount of the black ash range impacted over time. So if you look at the blue line, that's 95% basal area loss. You can see where it was quite low in 2020, maybe 5% or so, but steadily increases to nearly 60% by 2035 and almost 100% by 2045. And I'll spare you the maps, but we did this for our best case scenario too, the one at only 15 miles per year spread. And it's not appreciably better of an outcome. So here we can see that more than 95% of the range of black ash with 95% basal area losses occurring by the year 2045. If you compare the results between these two spread rates, you can see that the best case scenario is marginally better. Here, the blue line is the 50 kilometers per year spread, and the orange is 25 kilometers per year spread. The values are for area with any basal area losses. We see marginal difference between the two because emerald ash borer is already so widely established across the range of black ash today. So that's pretty depressing, but it gets worse. So you remember the tribal nations impacted by the expanding EAB infestation? Well, more than 70% of them were in areas with EAB present by 2020, shown in the blue line. The orange line is the 50-kilometer spread per year, which indicates nearly all of the tribal nations within the range of black ash will have EAB by 2025-ish or so. That's pretty spot on based on our latest EAB detections over the last couple of years. Even in our best case scenario, represented by the gray line here, it suggests that it's going to happen before the year 2030. So in the next year to 5 years, all of our tribal nations are going to have emerald ash borer within their footprint. But point data and tribal land holdings only tell part of the story and grossly underestimate impact to Indigenous culture in our region. So to account for that, we pulled the latest U.S. Census data from 2020 and factored in the number of people per household who identify as Native American within our study area. And this is what we found. The green bars are the observed number of Native Americans residing within the area invaded by emerald ash borer. The blue line is the observed cumulative proportion of Indigenous people potentially impacted. As of 2020, it was already over 90% of the Native American population in states with black ash. The orange bars and lines show the results under the 50 kilometers per year spread scenario. So you can see that most of the Native Americans are going to live in areas with emerald ash borer by 2025. To quickly summarize those numbers, by 2035, more than 75% of black ash basal area will be lost across 86.6% of the range, that's US and Canada, impacting more than 747,000 Native Americans, or more than 98% of the population in the US alone. And in less than 25 years, more than 95% of the black ash basal area will be lost across nearly 100% of its range in the US and Canada, impacting all tribal nations and First Nations people that value black ash as a cultural keystone species. So that's a pretty bleak forecast. But is there any hope? So certainly in post-invasion forests, surviving black ash regeneration faces many challenges, including loss of an ash seed source, which creates this orphan cohort of ash without surviving overstory or any newly germinated seedlings behind it. Loss of an overstory can also affect the hydrology of some sites, shifting them from forested wetlands to open wetlands. The establishment of invasive plants or the proliferation of sedges can also limit ash regeneration. And heavy deer browse can take a toll on vigor and growth of that ash regeneration. And of course, the persistence of endemic EAB populations affects ash survival as small diameter stems respond to gaps and grow into larger, more vulnerable size classes. EAB sticks around at some low level and doesn't tend to drop out entirely out of these stands. However, black ash is resilient. We find seedlings and saplings in post-invasion forests, which give us some young cohorts to continue to protect. And also on a positive note, there's considerable engagement with Indigenous communities and efforts are underway across the region to preserve black ash. So increased awareness has led to strengthening partnerships and communication as we increase monitoring efforts and implement management strategies in affected black ash stands. It's been, one of the highlights of my career so far is being part of these partnerships and communications where we have not just tribal nations and federal agencies, but we have universities and state agencies that are doing novel things now to try to work together and try to solve this issue that we're having. In turn, strengthening partnerships and communications is improving access for the harvest of basket quality logs on both private and public lands in many areas. So as states and private citizens are learning more about this struggle, they're opening up some of their lands to be able to salvage some of these materials. So it's leading to more opportunities to salvage basketry materials in some areas before they're lost entirely to emerald ash borer infestation. Also, seed collection efforts across the region have been renewed with a surge of webinars, trainings, and guides in recent years. So objectives of the seed collection include, immediate propagation of ash seedlings, as well as long-term storage of genetic material in many cases. There's also been a newfound emphasis on methods development and evaluation in black ash habitats specifically, with many projects underway, including things like the evaluation of management tool combinations in promoting black ash regeneration. So that's using silviculture and biocontrol and insecticides, but in black ash systems and in different combinations to evaluate how well we can promote black ash regeneration early in an EAB invasion. We're also doing things like injection of seed trees to keep ash seed raining down through an EAB invasion in areas that we want to keep black ash as a component. The assessment of black ash genetics across the region has kind of improved, and a lot more people are working on that and sharing genetic data with the geneticists in the region. And development of recommendations for long-term storage basket logs is another example of this methods development and evaluation. You remember in that basketry process, the pounding of logs is often a bottleneck to salvaging materials. So if we can preserve logs and not have to worry about pounding them right away after the harvest, that'll make long-term storage much easier than having to pound everything into splints right away. So while EAB's impact on black ash and indigenous culture is indeed a dire situation, the increased awareness, opportunities, and partnerships among land managers, scientists, and indigenous communities brings me hope and makes me believe that the final chapter in the story isn't yet written. So with that, I want to close with some acknowledgments. This is by no means a comprehensive list, but I'd like to thank several people, especially our tribal partners, who have generously shared their traditional ecological knowledge, culture, and love for the outdoors. This type of work wouldn't be possible without their support and passion. So thanks for sticking with me to the end, and I'll leave you with these images that represent what we're trying to protect, and take any questions if there's time.
All right, we do have a little bit of time here. So do we have any questions for Nate?
I don't have the chat pulled up, so if you see anything in the chat, let me know.
Yep, so we did just get one here. Has there been any progress in identifying genetically resistant trees?
Yeah, there's a lot of work looking at genetic resistance in black ash. And sadly, we don't tend to find a lot of trees that show promise compared to some of our other like other ash species like white ash or green ash. Um, but there are some that show some promise. You take, for example, that one tree in the stand that I've been assessing for several years that has a healthy crown. Oftentimes you'll find a tree that might have a healthy crown, but it's the trunk is got some old wounds from emerald ash borer, but it's still somehow hanging on. But like this tree in particular is doesn't show any signs of EAB infestation at all. So there are some trees like that around, and certainly we're working with geneticists to try to get that material and propagate it to see if it actually, when tested against higher densities of EAB, what kind of tolerance it has.
So we've got a few more questions that have come in now. So our next one is, do we know where the emerald ash borer goes after die-off to impact future trees?
Yeah, so I kind of mentioned that the EAB populations don't really bottom out to zero once they roll through the first wave and kill off all the overstory trees. And that's generally because there's enough ash that's kind of hanging around in some sort of decline that there's always this kind of low level uh, population of EAB. So then when you do have a tree that grows into a larger diameter class, like, maybe you have a whip that's 1 inch in diameter and the overstory's been removed. So now it's responding to a lot more light conditions and it's putting on some growth and becomes a 2 and 2.5 inch diameter tree pretty quickly. Um, that's getting attacked fairly often. So EAB doesn't really, well, at least in my experience, I haven't seen it like disappear from any stands. It just the population crashes and becomes really low, and then is still present enough to respond to any trees that are, surviving.
So our next question, someone is asking, is fall gold black ash a promising tree?
I'm sorry, say that again.
Is fall gold black ash a promising tree?
Yeah, if I remember correctly, that's the one that's a cross between the Asian Manchurian ash and our native black ash. Um, and yeah, certainly Manchurian ash shows a lot of potential for resistance against emerald ash borer. So, I think that it needs to be tested and evaluated under some different beetle pressure densities. But I haven't worked with it directly in the woods or in any other situations, so I can't really say for sure. But I think it would be worth testing if it hasn't already been.
So our next question is, what about the introduction of wasps? Has there been any progress there?
Yeah, so there's been a lot of biocontrol stuff done, right? And we've in the last couple of years we've been working with our colleagues in APHIS to actually test it in black ash, and I know that we've got several studies that are underway in Wisconsin and New York, and I think they're setting some up in Maine, um, and they're trying to see if we can include biocontrol releases with things like insecticides. So we're trying to protect some of the overstory seed trees with insecticides as well as do releases. Um, and historically, it's been kind of a challenge to work in black ash just because by the time you find it infested, those trees are often so far in decline or they decline so rapidly that they haven't been able to uptake the insecticide very well. But we've been doing a better job locating sites with very low EAB densities. So several of these projects are now underway, and it'll be really interesting to see what kind of results we get. But that's part of what we mentioned in the earlier methods development in evaluation projects, is just looking at things like that, the biocontrol agents, combined with insecticides, combined with some silvicultural treatments to open up the canopy and see if we can get more of a cohort of EAB, or not EAB resistant, but a small cohort of young ash regeneration present, that when you lose most of those untreated overstory black ash trees in a site, you already have a really good, strong cohort of black ash regeneration that will survive that first wave of EAB because they're so small.
So our next question, I think this one's a pretty good one, is someone is asking, what can the average person do to help?
Yeah, I mean, that is a good question. You know, certainly in areas that I work, you know, if people have black ash on their properties, um, you know, to be able to allow access to, indigenous log harvesters, for instance, that oftentimes black ash, it's not giving you any kind of commercial value from a timber management standpoint, but it could provide like a lot of value from an indigenous perspective. So allowing access to some of that resource is a good thing. And I think anything that we do to promote awareness and kind of these partnerships where we work together, I think is very beneficial in the long run. So I know that the folks that I work with are very appreciative of the support, um, and value, whether it's coming from another agency or the public at large.
Okay, so our next question here, do other ash trees have the same kind of, I think they're trying to say porous ring as black ash trees?
Yeah, so all ash trees are kind of that ring porous, the ring porous growth. Um, so if we cut a black ash and a white ash and a green ash, they'll all have those large early-wood vessels. Um, so what we've looked at is whether or not we can use some of these other ash species, even though they don't have the cultural significance of black ash, but can they be used in basketry? And in some cases, they may be able to be used for handles, things like that. But in general, they generally don't have the same kind of mechanical properties as black ash once they're pounded. They don't tend to have the same flexibility and strength. Um, but yes, they do all have, all ash trees are ring porous.
See, our next question is, what is the best way to protect new saplings during growth from emerald ash borer?
Yeah, so new saplings, you don't have to do much. So if we can get regeneration started, generally emerald ash borer isn't attacking this black ash regeneration if it's less than an inch in diameter. So if you've got seedlings and saplings that are less than 1 inch in diameter, they generally are going to be pretty safe from that first wave of EAB. So you lose all the overstory trees, and that's when you have these gaps that are created, a lot more light conditions. And as long as it doesn't mess up the hydrologic flow so much that these things get swamped out, they'll start putting on growth. So you don't really there's nothing you have to do in terms of like a chemical treatment on that really small diameter stuff. If you have black ash recruits, something that's maybe still in the understory but has a larger diameter. For instance, if it's 3-4 inches in diameter, a lot of these trees already start to get that more furrowed bark, which make them a lot more attractive to, dispersing adult emerald ash borers. The females like to stick their ovipositors in these bark crevices and lay eggs, as opposed to really smooth barked stems. So those you would have to treat with some sort of chemical to protect them. But usually what we're doing is trying to protect a few seed producing overstory trees that can produce a lot of seed, and keep ash seed raining down in these habitats, and just get those very small diameter seedlings and saplings established. Those will be protected. The emerald ash borer, for the most part, is going to skip over most of those. So at least for the first wave of EAB, you don't have to do much.
So I'm just going to have these be the last two questions here. So the first one is, are the black ash trees within areas of higher water flow surviving at a higher rate?
No, that's a good question, and it's not. It doesn't look that way. So, we haven't found any evidence to suggest that black ash tree that's maybe in an optimal growing condition is more vigorous and better able to protect itself. It's still just as vulnerable to emerald ash borer as some of these trees that may be putting on less radial growth.
And then the last question we are going to do is there a way to help support the indigenous tribes? Are baskets sold online?
Yeah, I think that there are often a ton of markets that the baskets are sold at. I think some are probably available online, um, but a lot of them are in person. Um, for instance, I know this weekend there's a in the Northeast, up in Maine, there's a big Wabanaki winter market that's going to have demonstrations and a lot of basket makers and a lot of things for sale. Um, and supporting indigenous communities through that is appreciated. But also just you know letting them know that you're interested in saving black ash is worthwhile as well.
All right, folks. I think that'll be all the questions we're going to get for now. That was a lot of them. And thank you, Nate, for sharing all your knowledge with us. We really appreciate that. I will get the recording for